Alright, here we have an elastic collisions problem. It's actually a pretty good example of what really happens. We have a golf ball being hit by a golf club. And the golf club is going to hit the ball, or right before the ball is hit, it's going to have a speed of 40 meters per second, and it's going to have a mass of 2 kilograms. The golf ball is going to have a mass of 0.046 kilograms. This is an elastic collision. And that's actually intentional. These things are designed to be as elastic as possible because that conserves energy. You want as much energy as possible going into the ball, so it makes sense. Alright? So, we have this. Now, an elastic collision, as we know, two things are conserved, both momentum and kinetic energy. So let's set up our two equations. Okay? Our momentum equation is going to look like this. Okay, we got the mass of the club times the initial velocity of the club plus the mass of the ball times the initial velocity of the ball is equal to mass of the club, V club final, plus mass of the ball, V ball final. Alright, and we plug in what we know, we get 2 times 40 plus 0 equals 2 times V club final plus 0.046 V ball final. Now, as you can tell, this is obviously not going to be solvable. It's got one equation and two unknowns. So of course we need our second equation, our kinetic energy equation. I'll save a little space, go over here. Kinetic energy equation, we have 1/2 mass of the club, velocity of the club initial plus 1/2 mass of the ball, velocity of the ball initial equals 1/2 mass of the club, V club final plus 1/2 mass of the ball, V ball final. Now I like to cancel out the 1/2s immediately, save some space, save some time, and we get 2 times 40 squared is equal to 2 times V club final plus 0.046 times V ball final. Now, in this particular case, we have an absolutely disgusting two equations and two unknowns. It is solvable. Alright, and so let me show you the first couple steps of solving it. Okay, I started here, and when I solve this equation, I get that 80 minus 2 VC final equals 0.046 VB final. Okay. Now from here, I would divide through and I would get VB final equals 1739 minus 43.5 VC final. I would then plug that into this equation and I could solve it from there using the quadratic formula. Unfortunately, that is going to be a pretty messy thing and there's a lot of places you can go wrong. So my advice instead is to go to Wolfram alpha. Okay, you take this equation right here and put it in there, and you put that equation right there in there, and you separate them by a comma, okay, and you should get out results. And it'll give you two sets of results. The two sets of results I got were now obviously it's the first set of results that are correct. This is our answer. And the reason is that this matches our initial conditions. Okay, when you solve these two equations, you should get two possible answers, one of which is going to be the initial. Okay? So whatever one is your initial result, which is 40 meters per second and 0 meters per second, is obviously not going to be our final. And so we get velocity of the club is 38.2 meters per second, and the velocity of the ball is 78.2 meters per second. Now this makes sense because when you think about a golf swing, right, it goes through, you don't see the club slow down much. The ball seems to, it might slow down a little bit, but in this case, it's only slowed down 1.8 meters per second, which is not that noticeable. So it would make sense and it's consistent with what we'd observe, whereas the ball is going to be going quite fast. All right, there's an elastic collision.